What up, y'all? Happy Tuesday. Go Dogs as always. Miss Koehl probably wants to say go Vols, but that is the lower of the lowest of the SEC schools. So go Dogs once again. Happy Tuesday. Welcome back to episode 2 of Don't Fail with Siegel and Koehl. We finally came up with a name, and we are going to go ahead and jump right into things with surface area. If you did not watch the live class yesterday or you didn't go to the live class, make sure to revisit some of the major concepts that we talked about on Monday. All right, Ms. Koehl, go ahead and start us off.
Awesome. Okay, so just a quick reminder, surface area is like we are wrapping a present. It is the total area around the surface of a 3D object. So in order to find the surface area of this rectangular prism, we're going to need to find all the areas for each base. So there's going to be 6 bases, and there's a little cheat sheet right here that says top equals bottom, left equals right, and front equals back. That means that the opposite sides are congruent in this rectangular prism. So in order to start and find the area of this front rectangular shape right here, we are going to take what we learned last week and find the area, which is base times height. Well, our base is 12 feet, right? Because it's that bottom line. And then the height is going to be 10 feet because it's that vertical line. So 12 times 10 is going to be 120 feet squared. Don't forget your units. And that will be the area of this large rectangle. However, remember there are 2, but we'll get to that later.
Miss Koehl, will you write 120 feet next to the front on the right, where you wrote the word front?
Oh, yes. I understand what you're saying now.
Thank you so much.
120.
Awesome. That way we just know what we're talking about for each side. And then will you write 120 next to the back as well?
Of course I will, because they are congruent, so they equal the same.
Awesome job. Thank you.
All right, of course. So then I guess we can move on to this side one, because it looks like we need to do this one. So the one that I'm shading in blue, it has a different base than our front one. It has a base of 2, also known as the width, but we will get to that later. The base of this small rectangle is 2, but the height's going to be the same as the height over here, which is 10 feet. So what we'll do is 2 times 10, and we will get 20 feet. So I will write over here that this equals 20, as well as this one equals 20. And then we have one more to do. Oh, no. I get too excited with the eraser sometimes. Okay. Final one is going to be this top one right here. Now this one may look a little tricky, but it's going to be the same, right? So we have our base is also going to be 2 feet, because remember, these lines are also congruent. So we will take 2 and we will multiply it by this base, which if we flipped it on its side, it would also be the height. So that would be 12, because this line and this line are also congruent. So 12 times 2 is 24, and I will write that next to the top and the bottom.
All right, so I think we're done, right?
Well, Coach Siegel, just like our finding the total composite area of our 2D shapes last week, we are going to do the same thing with finding the total surface area of our 3D shape, which means we are going to add up all of these numbers, the 24, the 20, the 120, but remember, there's 6 total. So the 120 here, the 20, and the 24. We are going to add up all these numbers together. And I will do it in my calculator head because I'm just that smart.
And just to clarify, y'all, the reason why there are 6 is because this is a rectangular prism and there are 6 faces, and the opposite faces are congruent to one another.
So if my math is correct, the total surface area would be 328 feet cubed.
Squared.
No.
Because the reason why it's not cubed is because cubed is for volume. It is squared because of you're finding the 2-dimensional area of each side, adding it together. All right, y'all. So that's actually a major misconception that a lot of students get confused with. They remember volume from 5th grade, and then they tie it into surface area. So it's really important to remember that it's just feet squared because you're only multiplying feet by feet. Just because there's 3 dimensions, you're still finding the surface area of a 2D shape, which if you go back to our nets is how you actually find the surface area, which will actually be our next question. We're gonna go ahead and click pause and we will get you to the next shape. All right, so what I want you guys to do is I want you to click pause here in a second, but I want you to find the surface area of this square pyramid. Remember, it's a square pyramid because it has 4 triangles and it has a square base. And remember that you still need to find the area of each triangle. And you do that by doing base times height divided by 2. The way that you find a height is through a straight line through the middle of the triangle, or you can do it to the side, and that's going to form a right angle, and that's going to show you how tall or what the altitude of the triangle is. So go ahead and click pause in 3, 2, 1, and come back when you have your answer. Welcome back. Miss Koehl is going to go ahead and work it out.
Okay. So there's a couple ways that you could find the area of this square, which I'm going to do first. You could see that it's 1, 2, 3 by 1, 2, 3. And you could get 9 by multiplying 3 by 3, or you could just count all the squares inside. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total area of this square is going to be 9 units. Don't forget, if you aren't given units, just write units. So then the next part is going to be finding the area of these triangles. Now, Coach Siegel said to draw it in the middle. I'm someone who kind of gets a little neat with my drawing, so I like everything to be on the side. Personal preference. As long as you are drawing to the top of the triangle, this also makes a right angle because they are 2 straight lines that make a 90-degree angle. So the base of my triangle is going to be 1, 2, 3 because there are 3 squares that take up this line. So I will write over here, my base is 3. And my height, I count 1, 2, 3, 4. It's going to be 4 units up. So 3 times 4 would be 12. And then if we remember, we have to divide it by 2.
Or multiply by a half.
Or multiply by a half, exactly. Thanks, Coach Siegel. So my total area for this one triangle is 6 units.
Squared.
Squared. Squared. Don't forget that, like I did. So, since we know that this one triangle is 6 units squared, and this square is 9 units squared, we would do 9 plus 6 plus 6 plus 6 plus 6, because there are 4 triangles. Or you can just do 9 plus 6 times 4. We can use some fun PEMDAS and use order of operations. 6 times 4 is 24, plus 9 equals, my brain's hurting, 33 units squared.
And just to clarify, y'all, what we just did is we found the surface area of this square pyramid. Meaning, if we built this pyramid up and we put all those triangles up together and built one of those pyramids, then all of this space on the outside of this 3D figure would be 33 units squared. That's how much wrapping paper we would need to cover the outside and the bottom of the shape. We're going to go ahead and pause and move on to the third problem. All right, y'all, here's question 3 and our final challenge question. It says, which box below has the larger surface area? And one thing I really like having students do is to make a prediction. So without doing any math, I want you to take a second and look at it, and I want you to decide, is it box to the left or is it box to the right that has the larger? Is it A or is it B, as Miss Koehl is writing now? So don't do any math, make your prediction in 3, 2, and 1. Now Miss Koehl is going to work out the surface area for both of them, and we are going to see if your prediction was correct.
Awesome. Okay, so I'm going to start off with box A. So I wrote down here that the length or the base is 10 inches, the width, which is that side, is 1 inch, and the height, which is that vertical line, is 3 inches. So to find this front base like we did earlier, we're going to take our length and multiply it by our height, or our base times our height. So 10 times 3 would equal 30 inches. So I'm going to go back here because if you remember, the front and the back both equal the same because they are congruent. We will go to this small box to the right next. The width or the base is 1 times the height, which is 3. So 1 times 3 is 3. So the left and the right both equal 3. My computer is moving because my cat decided to lay right there. Gotta love him. All right, finally, this top one right here. Remember, since these lines are both congruent because rectangles have 2 sets of parallel lines, you know that the space is also 10. And then you know, since exactly what I said, the 1 is also going to be 1 here because both of these lines are parallel. So you would have 10 times 1, which is 10. So you know the top and the bottom both equal 10. Now, like we said earlier, you just add all of them up like you would for a composite shape. What I'm going to do is I'm just going to multiply 30 by 2, 3 by 2, and 10 by 2 instead of adding them together to get 60, 6, and 20. And then I'll add these up because it's the same as adding all of them together. I just doubled the sides because there are 2 sides. So 60 plus 20 is 80, plus 6 is 80 inches squared. So this one has a total surface area of 86 inches squared. Now on to box B. I'll use red for Coach Siegel. For this one, we have a base or a length of 5 inches. So 5 times the height of 3, which is over here, because this line would be parallel to this line, you would get 15. So the front and the back are both 15. And I'm going to erase this because I'm neat. This next one, we have a base of 2 and a height of 3. So 2 times 3 is 6. So both the left and the right are 6. And finally, let's get this top one. So if we remember how the lines are parallel or congruent, this one is also going to be 2. So we'll have 2 times 5 because these are also parallel. So 2 times 5 would equal 10. So the top and the bottom are both 10. 10 times 2 is 20. 6 times 2 is 12. And 15 times 2 is 30. So this would be 50 plus 12, which is 62. So box 2 would be 62 inches squared. So I hope y'all picked box A because you can see it is 24 inches bigger.
Yep, so the space that covers that rectangular prism is 24 inches bigger, meaning you would need 24 extra inches of wrapping paper in order to cover the box. So hopefully you can reevaluate your prediction. And yeah, so hope you guys have a really, really good Tuesday. Make sure to complete all former assignments. Make sure you do the SEL check-in for today. And then also I have a fun little assignment for you to work out as well. So see you guys
See you Wednesday.
Wednesday. Bye.